So what if you could give an AI an open book exam instead of a closed book memory test? Well, that's pretty much the huge idea we're going to unpack today. We are talking about a technology that is making AI way smarter, way more accurate, and a whole lot more useful. All right, let's get into it.
You've all seen this, right? You ask a chatbot something about, I don't know, an event from last month, and you get that classic response, "Sorry, my knowledge cuts off in 2021. Or even worse, it just straight up makes something up. This is the exact problem that this whole new approach was designed to fix.
So what's really the difference here? Well, just look at this. On the left, you've got your standard large language model, or LLM. It's basically just guessing, based on whatever old data it was trained on. It might be right, but it might also be completely hallucinating. Now look at the right. The model first retrieves current, relevant info, and then it answers. The result? A correct answer based on actual facts.
And that leads us to a fundamentally smarter philosophy for how we build AI. Instead of trying to make a model memorize the entire internet and just crossing our fingers that it remembers things correctly, we give it the power to look things up. It sounds like a simple shift, but trust me, it changes absolutely everything.
And this quote just nails it. This is the mantra for this entire system. Don't memorize everything. Fetch what you need, then answer. It's so intuitive, right? It's efficient. And honestly, it's how the smartest people work. They don't know everything off the top of their head, but they're pros at finding the right information when they need it.
So this whole fetch, then answer approach, it has a name, Retrieval-Augmented Generation, or RAG for short. As you can see right here, it's an architecture that basically bolts a search engine onto a really powerful language model. You get the best of both worlds, this massive, almost limitless knowledge base, plus the ability to generate text that sounds completely human. Okay, so how does this all work under the hood? It might sound super complicated, but it's really just a pretty straightforward 5-step flow. Come on, let's walk through it.
All right, first you ask a question. That's the user query. Simple enough. Next, your question gets turned into numbers, into what's called an embedding. Just think of it like a unique fingerprint for the meaning of your words. For step 3, the retriever uses that fingerprint to instantly search a special kind of database for any documents that have a similar meaning. Then, step 4, those documents it found are injected right into the prompt along with your original question. And finally, the LLM generates an answer using both your query and all that fresh new context it was just handed.
Now, what's really cool is that this isn't just theory. These are real tools that you can use today. As you can see here, that retriever is powered by some really clever search algorithms. The info is all stored in a vector database. You might have heard of things like FAISS or Pinecone. That text-to-number stuff is handled by an embedding model, and of course the final answer comes from a powerful generator, an LLM you definitely know, like GPT or Llama.
But here's the thing. RAG isn't just one single, rigid technique. It's more like a whole family of approaches that have been evolving over time, with each one adding a little more sophistication and power to the basic idea. Let's take a look at the main flavors.
First, you have what's called naive RAG. That's the basic 5-step process we just covered. Then, things get a little smarter with advanced RAG, which adds extra steps like re-ranking the search results and filtering out junk to find the absolute best info. And finally, you get to agentic RAG. This is the real next-level stuff, where intelligent agents decide what to search for, if they should use other tools, or even if they need to double-check their own work.
So here's the bottom line. The reason this all matters. This isn't just some cool concept for a research paper. It's a technology that is solving real problems right now by making AI more reliable, more trustworthy, and capable of working with your own private, totally up-to-date information.
And the applications, they're popping up everywhere. You can use RAG to build a tool that lets you literally chat with your own PDFs and documents. It's the engine behind smarter customer support bots that actually know about the latest product updates. Companies are using it to create internal assistants that are experts on company policies. The possibilities in law, medicine, software development, they're just massive.
Getting some ideas? Well, here's the best part. You don't need a giant research lab to build one of these systems. For any developers watching this, putting together a basic RAG app is surprisingly doable. Let's look at a simple tech stack you could use to get started.
You can literally use a standard web stack, something like React and Node.js. Then, for the AI parts, you just hook into the OpenAI API for both the embeddings and the LLM, and you can use a free local vector database like FAISS to get off the ground. All the pieces are just sitting there, waiting for you to put them together.
And that brings us to the final, and maybe the most exciting question of all. RAG gives AI the ability to securely and accurately learn from your data. your documents, your emails, your company's entire knowledge base. It's like giving it a library card to your own private universe. So the only question left is, what will you teach it first?